We'll proceed in tedious calculus problems. Okay, so we are pursuing discussion, long discussion on tedious calculus problem. The idea is not to solve the problem the way it is written in the book. Because nowadays, what we see is the modern way of calculus. What we are trying to achieve is through the primitive way of calculus. Write a pseudocode on top of it, then write the chain, modify the pseudocode into multiplication and division, and then multiplication is replaced by a kind of integral calculus, and division is replaced by differential calculus. This is the algorithm, this is what we are using. Anyway, with that we have proceeded along, and we are in RC circuit, resistance capacitor circuit. Then we are in a phase 2. We have calculated resistance model of a capacitor. If this is a resistance and this is a capacitor and it is connected across a battery, the load is resistor, the load is resistor capacitor combined connected to a battery. This is what we have been seeing. There is a battery source 3.7 volt that we have taken as an example. Battery source 3.7 volt. Across battery source, one load is connected. That load comprises one resistance, and in resistance there is another item that is connected, that is a capacitor. Resistance model of the capacitor, I can replace capacitor with a variable resistor. That is the resistance model of a capacitor. Variable resistor, resistor and variable resistor. The fixed resistor is capital R and variable resistor is X. Now we have calculated formula of X. Please watch previous video, and for formula of like if any time I current is flowing, then R plus X into I is the net, is the kind of R plus X into I, that is the net voltage drop across this load. If I current is flowing and resistance is R plus X into I is the net voltage drop across this, and that is nothing but Vs, that is fixed. So if that is the case, if that is Vs, then R plus X equal to Vs by I. I is a variable current, and we know the formula of variable current is I0 e to the power minus t by RC. I0 is the beginning current, that is Vs by R. That become R, settle it down. Variable resistance model of a capacitor X equal to capital R in braces e to the power minus t by RC minus 1. Anyway, now we have seen that voltage across capacitor. This is what we saw. Next is what is the kind of phase circuit. Phase circuit in the sense that what is the difference between current and voltage as far as phase is concerned. Phase is concerned in the sense because we have seen it that if current is maximum across the capacitor, then voltage is zero. If voltage is maximum, then current is zero. When current is maximum, voltage is zero. Again, when voltage is maximum, current is zero. Okay, to prove it, we took a switching voltage source. Switching voltage source means if this is a battery, this is positive and this is negative, and it is connected across a RC circuit, there is a capacitor. So at the beginning, there is a maximum current and voltage drop across capacitor is zero at the beginning. Okay, after some time, voltage drop across capacitor is same as battery, but current is zero. Now change the polarity of the battery. Now this is positive, this is negative. In that sense, capacitor is charged, this is positive, this is negative. Where battery is, this is positive, opposite direction. Then it will tend to make the current flow in opposite direction. So battery will be discharged to zero. Battery will be discharged to zero, and one moment will come, the voltage across battery is zero. At that time, this current, earlier the current was like this, now current is like this, and it is flowing maximum. That is the scenario. Okay, after that, this capacitor will start charging the bottom part as positive and this part as negative. Okay, after some time, the voltage drop will be maximum and current will be zero. So current is flowing maximum zero, then other direction maximum zero, then other direction maximum zero, other direction maximum and zero. Direction of the current is, if I consider this direction anti-clockwise as positive, then clockwise is negative. Okay, similarly, if I consider this is capacitor, this is positive, this is negative, then sometime it is like this, that is the positive voltage. If it is switching the polarity capacitor, then it is negative voltage. So it looks like that if I draw the current diagram beginning at the time equal to 0, current is maximum, and then at time equal to something, then current is 0. Then again at time equal to something, current is maximum in reverse direction. At time equal to something, it looks like it is making a sinusoidal wave. Similarly, voltage when time equal to 0, voltage is 0. When time equal to the time at which current is 0, the voltage is maximum. Voltage is going, it is also going like a sinusoidal wave. But there is a phase difference. There is a phase difference in the sense, if I consider time as angle, time as a radian angle, I can take radian angle, right? So radian angle is like a kind of, all right, like if I have a circle, then what is the perimeter of the circle? If there is a circle like this, and this is center and this is the radius. If radius is moving like this, then what is the perimeter of the circle? Perimeter of circle is radius into the angle. If angle is 2 pi, up. Okay, leave it. Just leave it. Okay, now I am just saying, if there is a circle and its radius is r, then what is the circumference of the circle? Circumference of the circle is r into 3.14 something. Okay, then that, can I consider 3.14 2 pi r? That is the circumference. That will be 6.28 something like that. Okay, if I say that circumference of the circle is 2 pi r, then it is 2 pi multiplied by r. Then this angle, the angle what we are seeing, this is 2 pi. Okay, means if I move a radius that makes a circle, if I move radius from 0 to 90 degree, then this length is quarter to the full length. Okay, if full length is 2 pi into r, then this length of this arc is pi by 2. Then people started saying, consider this angle as pi by 2. Consider the full angle is 2 pi. Angle into radius is the circumference. Okay, that is also come as angular velocity. Angular velocity also is radius. I'm sorry, the circumference velocity or centripetal velocity is radius into the angle. Angular velocity. Angular velocity is how many angular radian it is sweeping per second. So every second, if something is making one round, then it is the velocity is considered as 2 pi per second. 2 pi angle, it is sweeping per second. 2 pi per second. Okay, anyway, that is the story. So now we found that voltage and current, they are very similar to like a sinusoidal wave. If they are similar to sinusoidal wave, then sinusoidal wave. If they are similar to sinusoidal wave, then, but this is still a magnitude. Minded, mathematics is not complete till we are not introducing, until we introduce a vector. Okay, if I have a circle, what is the equation of a circle? What is equation of a circle? Y equal to square root of a square minus x square. Anytime the vertical, if there is a circle, it is two dimensional, where vertical is y axis, horizontal is x axis. Y equal to square root of a square minus x square. That is the equation of y. What is the circumference of the circle. What is the length of the curve this circle is making? Okay, if I try to find out, then I cannot calculate with the y and x relationship. Okay, I have to do something more. So then we go with the vector analysis. Vector analysis in the sense, if I represent this line, any curve line through vector, any line through vector, if I have to find the length of a line, then if I represent a line as a vector and calculate the magnitude of the vector, I get the length of the line. This is how vector comes into the picture. Whatever, if we need to include x and y together, if I want height at any moment, then y equal to square root of a square minus x square works. If I want change in the height at any moment, when there is a unit change in x-axis, how much change in the height I see, then dy by dx is sufficient. But if I say, if there is a y and x, there is a curve like this, what is the length of the curve? Then if someone talks like this, what is the length of the curve? The length of the curve, for that we need many points on the curve. If someone is asking, what is the length of the curve? Okay, what is the length of this line? Then I have to think about many points on this line. This is x-axis and this is y-axis. This is a line. What is the length of this line? This is, consider this is origin. This is some point x comma y. What is the length of this line? Neither y equal to square y equal to fx function over x will work, nor dy by dx will work. Not possible. Just calculate the length of the line. Not possible. Okay, for that we need to think about every point on this line, then only interdistance between point or something like that. That we need. If I take this point and this point, then through Pythagoras theorem, I can find the length of this line. But if this is tilted like this, it forms a non-linear line. In that sense, I have to take points where the length is linear and use Pythagoras theorem to calculate the each length and then add it. Or we go by something called a pseudocode. What is the pseudocode to calculate the line? Okay, pseudocode to calculate the line is get a vector representation of this line. If someone gets the vector representation of line, then he can calculate the magnitude of vector and he get the line. If this is origin and this point is x comma y, then this vector representation is xi plus yj. Just calculate x square plus y square square root, that is magnitude of the vector. You get the line. What is the inside of the vector? Talks about x and y component together. If I want to find the length of this line, then I have to think about various points. Each point consists x and y. Each point consists x and y. Each point consists x and y. Vector vector take responsibility of x and y point together. That's why vector is xi plus yj. It has x and y component both. In that sense, the magnitude of the vector is the length of the line xi plus yj. That is represented. But if I take a, instead of a straight line, if I take a kind of instead of a straight line, if I take a kind of a curve line, okay, where Mr. Curve went. Okay, so curve was here only. I don't know where it went. Okay, I have another curve. This is also a curve. This is LED. Okay, this is also a curve. Now I can make it any curve. I should not bend much. This is also a curve. What is length of this curve? What is length of this curve? Then someone would say divide it into many parts, and each part represent it as a vector. Each part represent it as a vector. Make sure that all parts are straight. Then calculate the magnitude of each vector and then add it. You get the length of this. Okay, this is not the approach we are going through. This is called modern approach. Okay, the primitive approach is that what is the, consider this is a straight line. This is a straight line and this is the end point, this is the beginning point. What is the length of this line. Then that is, if I represent this in a straight line, then this is xi plus yj. That is same as I plus y by xj. Same as I plus y by xj, where y is dependent upon denominator x. Okay, then what is the length of this? Length of this is same, I'm sorry, this is same as I plus y by xj in bracket close into x. Okay, if that is the case, where now we have two things. One is multiplication, one vector multiplied by x, and inside the vector we have y by x. We have division and multiplication both. Now in division y by x, y is dependent upon denominator x and x is independent component. In that sense, y by x will be changed into dy by dx and then whole dy by dx. And now we are in a phase to calculate the magnitude of the vector, right? So magnitude of the vector will be 1 square plus dy by dx whole square root into x. Whatever we are seeing this 1 plus dy by dx whole square root, this is a dependent component dependent upon x, that is independent component. Then multiplication of two items when one is independent and other is dependent will transform into integral calculus. So net length is 1 plus dy by dx whole square root dx, where x is from, if this is the line and this is x axis, I'm trying to calculate the length of the line, then this is x1, this is x2 on the x axis, x1 to x2. So this is also a way, but we came to vector representation. So in RC circuit or LR circuit, LC circuit, LCR series circuit, LCR parallel circuit, so many things, discussion will not be completed when we are not coming to vector. What is vector? If I have a resistor and if I have a capacitor and battery is connected, then current is flowing like this. What is vector? Vector is a something that energy has a direction, right? This is the energy, and it is direction is like this. Because this is a circuit, you can change the direction to round, you can change direction to a square, rectangular, whatever. That is not the direction we are talking about. Internal direction, internal vector, the vector that we see in the current, voltage, resistance, and capacitance, inductance, and this kind of scenario where vector will come. Don't fear, I would say, don't fear. But no discussion is complete until we talk about the vector, that is the direction. Because direction, what is the equation of current? Current equal to beginning current, that is I0 in RC charging circuit. Any moment current equal to I0, the beginning current, into e to the power minus t by RC. Now people mug up. Do the people see that it is a two thing? One is t is independent component and I is dependent component. Someone can say y equal to I0 e to the power minus x by RC, where x is time is x axis and this is current. Now again, now if I draw a line of time and current, it will form a kind of sinusoidal line. If it forms a sinusoidal line, it is again a curve. Okay, if it is again a curve, so any point on the line, I can represent it as t comma I, hope x comma y. Then from origin, I can have if this is point is x comma y, makes sense, right? If this is x-axis, this is y-axis, and x-axis represent time and y-axis represent current. If x-axis represent time and y-axis represent current, then current at any moment, current then or y equal to beginning current into e to the power minus x by RC. RC is constant, beginning current is constant, only variable is x. Then it will draw a graph, sinusoid, the beginning current is maximum, right? So at the beginning it will be maximum, then it will cut the x-axis, sometime it will go negative direction, then like this. If the DC voltage is switching, the way we gave the example, $1 trillion example. Anyway, so in that case, then I can represent this curve. I can represent this curve any point at x comma y or time comma current, any point. From origin, if I draw a line, that will make sense because it is now a position vector. That is Ti plus Ij. Hope, where from you brought this vector? We will see more on it. This vector representation will come as a Euler fundamental, and then reactive component means reactive component if I have a reactance or inductance and those kind of things, imaginary number and so many things. So it will come into the picture in that scenario. So that we will see. Anyway, we have calculated the phase difference. Now we know that in RC circuit, the if current is if current I represent current is maximum when it is time is zero. So if current is cos x, cos t, then voltage is sin t. How we prove it? Then the equation of the voltage drop across capacitor is voltage equal to charge by current, dV by dt equal to current by charge, current equal to C into dV by dt. So if voltage is represented as sinusoidal wave, then differentiation of sinusoidal wave is cos x. So if voltage is sin t, then current is cos t. They are they are in difference with 90 degree, because sine wave and cos wave, they have phase difference of 90 degree. 90 degree in the sense that when current is at a time equal to 0, when current is maximum, voltage is 0. After 90 degree as per a sine wave and cos wave, then when current is 0, voltage is maximum. Again after 90 degree, when the current is maximum in negative side, then voltage is 0. Again after 90 degree, then current is 0 and voltage is maximum in negative, whatever it is. So they have difference. How to prove it is current at any moment in charging circuit of voltage is C into dV by dt. If voltage is sinusoidal, the current is cosine. Then they have certainly 90-degree angle. What about resistance and voltage? This is the assignment that I was interested in. What is the phase difference between voltage and resistance? What is the phase difference between current and resistance? That's what we want. Okay, current equal to 1 by C dV by dt. Okay, if voltage is sinusoidal, then current is cos x. Resistance is voltage by current. So voltage is sine, then current is cos. It comes as tan t. Tan t. When t equal to 0, the internal resistance that showed by the capacitor is 0. When t is 90, then resistor is infinite. Actually, it is infinite. Because it is completely charged, voltage is maximum. Okay, then when it is pi, now 0, pi by 2 pi, then current is maximum in reverse direction and voltage is 0. In that sense, tan pi is again 0. So looks like the resistance is in phase with voltage, not with the current. This is what it looks like. So voltage and resistance are in phase, whereas current and voltage, they are anti-phasor. 90 degree. What anti-phasor I say? That is 90 degree. Then we talked about LR circuit. LR circuit is resistance and inductance. They are the battery. A battery has a load that is connected to a battery. A battery has a load connected to a battery. That load consists of a resistor and inductor connected in series, and they are connected to battery. The resistor is R and then inductance is L. That we can think about the variable resistance again. If that is the case, then what is the current at any moment? What is the voltage across inductance at any moment? The inductor component will have some internal property. An internal property is the rate of change in the current per unit time. If I multiply by the inductance, it will give the voltage at that moment. So the nature of inductor is, if inductor is connected to a battery source, DC battery, then immediately the current that will flow through the inductor will be zero, because there is a coil and coil is wounded, whatever, along a core iron or whatever it is, it will try to develop a magnetic field immediately. if current is there is a coil and current is passing through the coil, then immediately it will develop a magnetic field and it will oppose the flow of the current. So at the beginning there is no current and voltage difference will be high, and slowly it will start allowing the flow of the current. After some time, it will behave like a pure wire. Current will completely flow. But this inductor is an energy storage device. It will store some energy. When it is allowing the flow of the current, by that time, inductor will have energy. Anyway, then any moment, what is the voltage across the inductor? That is L di by dt. At the beginning, the change in the current per unit change in the time is very high at the beginning. At the end, when full current is flowing, there is no change in the current after some time. Then di by dt is zero. Then voltage drop across this will be zero. Anyway, voltage drop across a wire is zero, where resistance is zero. Now, if someone think about it, then voltage drop across R and L is Ri plus L di by dt equal to Vs, that is the battery. Now, someone is free to calculate the kind of then where is your primitive calculus? This is what we are talking. Primitive calculus we are trying to say here, because we know that voltage drop across inductor is change in current per unit change in the time. Change in current per unit change in the time. So change in voltage across the inductor, how fast current is changing per unit change in the time. So that is I by T. If I want to know that how much one entity is changing per unit change in another entity, like I gave example that I have two bags. One bag has orange and one bag has mango. If I drop one orange in the orange bag, then I drop four mango in the mango bag. Now, if I drop again one orange in the orange bag, then I drop four mango in the mango bag. Then, then after some time, then someone would say, looks like per orange then you add four mango. Then I don't know how many mango are there in the bag and how many orange there are in the bag. But one thing is for sure, if there are X orange in the orange bag, then there is 4X mangoes in the mango bag. How you calculate it? Because the mango by orange equal to 4. Per orange, there are 4 mango. This is what you are doing. So if orange is X, then mango is 4X. Division means per unit change in the denominator brings how many unit change in the numerator. So voltage across inductor is per unit change in the time brings how many unit of change in the current. But problem is that current change in the current per unit change in the time is not constant. When time equal to 0, at the moment when battery is connected to the inductor, at that moment time is 0 to time to 1 second, or time is 0 to time to 1 millisecond, 1 unit. 1 unit is not 1 second. It can be 1 millisecond, 1 microsecond also. So time is 0 to 1 unit. The current that I see the change in the current. Now when time is 5 to 1 unit, there I see the change in the current. The change is different. This proves that change in the current is dependent upon at what time we are calculating the change in the current per unit change in the time. So I by T, that is change in the current per unit change in the time, will be resolved as di by dt. If you remember, when we are calculating the length of the line, we represented the line as a vector. And then we said that vector is xi plus yj. It is same as I plus y by xj into x. Y by x, when the numerator is dependent upon denominator and y by x is there, it will be transformed into dy by dx. Similarly, the voltage across inductor is V equal to L I by T. What is change in the current per unit change in the time? But I is dependent upon T. It is not independent. In that sense, it will be transformed into di by dt. Now, anyway, now we have inductor circuit and it is Ri plus L di by dt equal to Vs. Now, anyone can calculate L di by dt equal to Vs minus Ri. Okay, in that sense, di di by Vs minus Ri di. Okay, okay, I can take this side and this side. So it becomes L di by dt equal to Vs minus Ri. L I can take that side. It becomes 1 by L, and it becomes di by Vs minus Ri equal to 1 by L. Now Vs minus Ri, consider Vs minus Ri equal to x. Then di equal to minus dx by r. So I can replace as minus 1 by r minus 1 by r into dx by x minus 1 by r. It will go on right hand side and it becomes r by L. This side L was 1 by L. 1 by r will go that side. It becomes r by L minus r by L dx by x. Integration is ln x. Ln x equal to minus r by L. Okay, now where is x from where to where? Now x equal to Vs minus Ri. Okay, at the beginning, the current is zero. At the beginning, the current is zero. So it will start from Vs. The x will start from Vs. At any moment when current is I, then x equal to Vs minus Ri. I believe it is all right. So it will start from the Vs to Vs minus Ri. Vs, Vs minus Ri ln x. That is ln Vs minus Ri by Vs. And that side, t we took that side. So it is minus R by L t. That is dt. Integration 0 to 2 is t. Okay, it becomes like Vs minus Ri. Vs minus Ri by Vs. Vs minus Ri by Vs equal to e to the power minus t by t R by L. Okay, now someone can settle it down. This is how some settle it down. This is what the current relationship will be there. Okay, so now people can derive the voltage also. It is similar to RC circuit. Now people can proceed and calculate the phase difference between current and voltage, or will try in the next session. The idea here is I am trying to find out there is another circuit possible where there is a voltage source and there is an inductor and there is a capacitor. Okay, so I have a kind of voltage source and I have a capacitor and I have a kind of inductor connected in a series. Can someone find out the equation of this? Okay, so there is a voltage source, battery is there. This is the battery, and the red is and black is there, that is positive and negative of the battery. And one is, this is 3.7 volt battery. This is a capacitor. I'm not talking about LCR circuit, LR circuit, I'm sorry, LC circuit. Now this is a capacitor, and this is one and other end. This is resistor that I can bypass. Now there is an inductor like this. Okay, this inductor, now I'll connect with the series. So I'll take out this resistance. There is a resistance here with the capacitor. So this is the capacitor and there is a resistance. I can desolder it. I connect a inductor here. So capacitor and inductor are connected as a series and they are making a load in front of a battery. Okay, now can someone deduce the formula that at any time what is the voltage across the capacitor? Okay, question is straightforward. If there is a battery, DC volt battery, and battery is connected to a load, and load consists of a series circuit. One is capacitor, one is inductor. Now it is connected to battery. What would be the voltage at the capacitor any moment? Means I want the voltage at the capacitor as a function of time. A change in the time, how the voltage across the capacitor would change, that is the question. So this solution lies in a fact that there are two things. One thing, let's consider that capacitor is completely charged. I took out capacitor stealthily, means in a kind of a cunning fashion. Silently, I took it out, this capacitor, and placed it across the battery and charged it completely. And then I connected the inductor source back to the capacitor. Make sense? Means I have a LC circuit. The capacitor is connected to an inductor. That's it. Where capacitor is completely charged. Now the voltage across the capacitor is maximum. Now inductor, it is as good as there is a battery that is placed against an inductor. Makes sense? If capacitor is completely charged and any load is connected to capacitor, capacitor starts behaving like a battery. Please watch our previous video where we have charged the capacitor and then we place the capacitor across LED, it glows. Means capacitor stores energy. Inductor stores energy, where a resistor does not store energy. So resistor, everything is constant. We don't need calculus actually. Anyway, so capacitor, now capacitor is connected to inductor. The problem is capacitor will start discharging. But at the beginning, the inductor will oppose flow of the current, but slowly current will start flowing. But inductor is an energy storage device. These explanations certainly you will not get anywhere. I have seen the book, reactance component, inductance component, Euler formula, then it will come into complex number, then it will be this plus this, and as per the Euler formula, e to the power j, e to the power jt will become cos t plus j sine t. Means what is behind this, no one knows. That's why Einstein came into the picture and said, only thing that is constant in this world is energy. Energy changes its form. So if you try to calculate the mathematics from one form to another form, concentrate on fixed thing. Fixed thing is energy. Energy does not change. In that sense, you will be able to calculate the parameter on the different form. If I am boiling a water and water is getting converted into vapor, then what is constant here is whatever the energy I am putting through the fire, that fire becomes the vapor energy. So energy does not change. It changes its form. Okay, I have typically problem energy cannot be created and cannot be destroyed. This is Einstein formula. Personally, I have problem is energy cannot be created. There are ways that energy can be created. Energy cannot be destroyed, that we will talk. But right now, consider energy cannot be destroyed. Energy cannot be created, that is true. Because no one can create the energy. But there are ways that we can create the energy. So it is not that energy cannot be created. Okay, I won't talk about energy cannot be destroyed, otherwise people will come into nightmare. They will not be able to sleep at all. So energy cannot be destroyed. So that is the scenario. So if capacitor has the energy, now this proof you will not get anywhere. Now this capacitor has energy, and if I know the energy of the capacitor, after some time, this inductor will be fully charged and capacitor voltage will be zero. Full energy of the capacitor goes is inside the inductor. Now inductor is fully charged, but the voltage, the inductor is fully charged and current flow through inductor is possible. Okay, in this circuit, and voltage drop across the capacitor is zero because di by dt is zero when it is fully charged. So at the beginning, when charged capacitor is connected across inductor, the voltage drop the inductor is very high. Current is zero, but slowly it will start behaving like a copper wire. No resistance. Current will start flowing. Di by dt is zero. But whatever, inductor will store the full energy of the capacitor. Now it is as good that inductor is charged from outside and it is placed against a discharged capacitor. Now slowly inductor energy will go into capacitor and this will be discharged. And this will start flowing like this, hop, 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 and it will come to a kind of oscillator. It will start oscillating. Okay, so we will talk more on this, but can someone give the formula of oscillator? Okay, at the beginning, there is a battery and it is connected to a load, and load is capacitor plus inductor. Okay, to solve this problem, voltage at any time, what is voltage across capacitor? People consider Consider this battery source is zero. Then what is the phenomenon it will show? Then add the battery. Okay, whatever the phenomenon it is showing as far as oscillating is concerned, then add the battery. What do you mean by? Anyway, now it is, what is the voltage drop across capacitor? Consider it is VC. This is what we want. Voltage across capacitor at any moment in the charging circuit of LC is VC. Voltage across inductor is LdI by dt equal to the voltage source, that is Vs. Now, current is same, since it is a series circuit, same current is flowing through capacitor and inductor. Now, capacitor formula is current at any moment of the capacitor is C dV by dt, C into dV by dt. Di by dt is C d2V by dt square. So it becomes V, that is voltage across capacitor, Vc or V plus V plus L into C d2V by dt square equal to Vs. Okay, consider that capacitor is fully charged, then Vs is zero. I'm not talking Vs into the picture. This is the first phase that they are connected independently without any voltage source. Then it is V plus L into C d2V by dt square equal to 0. Now here, can someone solve a algebraic equation, differential equation d2V by dt square r into L d2V by dt square plus V equal to 0. Okay, now people they think about, I believe we will cover this. So this is where this is called second order differential equation. Now Vs I am considering 0 in the sense that it will start oscillating if capacitor is completely charged. Still, this equation holds true there also. In that sense, now consider that V equal to e to the power st. Voltage is V. Voltage is a kind of exponential form. V equal to S e to the power st, or someone can say A into e to the power st, or just e to the power st. Then I can replace either e to the power st plus r into L s square e to the power st, because double derivative will be s square e to the power st only. Now it will be transformed, this equation will be transformed as R into C, sorry, L into C S square plus 1 equal to 0. So it will become S square plus 1 by LC equal to 0. Then S equal to square root of S equal to S square equal to minus 1 by LC square root. That makes an imaginary number. The square root of minus is imaginary. S equal to j plus minus j 1 by square root of LC, or j 1 by square root of LC plus minus j 1 by square root of LC, imaginary number, whatever it is. We have taken voltage at any time as e to the power st. Now this form, the solution for this is, we will talk everything here. The solution to this is that we have to divide into two parts. One is called A1 e to the power the first result plus A2 e to the power second result. E to the power first result is S, second result is S. There are two S here. One is J 1 by a square root of LC, and one is minus J 1 by a square root of LC. Now it becomes voltage at any time is A1 e to the power j. Consider 1 by a square root of LC. 1 by a square root of LC is omega. Then it is A1 e to the power minus j omega t plus A2 e to the power minus j omega t. This is the voltage that is we are seeing. Why j is coming into the picture, what it talks, that we will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 91 is the India country code. 9483160610 is the telephone number. Anyway, in this circuit, we got the voltage at some complex number. But voltage, the actual equation of what we have taken is voltage any moment of this LC circuit when there is no external voltage is there. If external voltage Vs we connect, then whatever voltage equation we are getting, we will add Vs to it. So it will become Vs plus A1 e to the power j omega t plus A2 e to the power minus j omega t. Vs we will add because it is not zero. When zero, there was no DC voltage in the circuit, then this is what Vc we are getting. Now with DC voltage we are attaching from outside, so we will attach in the voltage of the here. So this will oscillate, but there will be DC component, that is Vs. Anyway, we will see more on it.